Welcome friends to this new lecture of week 6, that is we'll start from soil acidity. So basically we'll be starting for discussion about the different types of problematic soil. So we are starting with the soil acidity now. Soil acidity is very important as far as the soil physical, chemical and biological properties are concerned, and we will be covering these following concepts. We will be covering what is first soil acidity, and then what are the natural and man-made causes of soil acidity, what are the different pools of soil acidity, and finally how to ameliorate soil acidity. Obviously, we cannot cover in details all of these. We will be having a we will be trying to give you a snapshot of different ideas, an overview of different of these topics, and we'll hope that you will learn in details in future by consulting different textbooks and reference books. So let us start with the soil acidity. Obviously, soil acidity is measured in pH units, and you know that pH is basically the negative logarithm of hydrogen and concentration, and it also considered as a master variable. So let me increase the mouse pointer so that minute please. So okay, all right. So we know that pH is basically the negative logarithm of hydrogen and concentration, and it varies from the pH varies from 0 to 14, and obviously when the pH is 7, that is called neutral, and when it is greater than 7, that is called alkaline condition, and when there is a less than 7 pH, that is in acidic condition. So pH is also known as the master variable as far as the soil analysis is concerned, because it governs different types of soil chemical, physical and biological activities. Different microorganisms are present in the soil based on the soil pH, and their abundance varies from one pH condition to another pH condition. Different chemical processes and biological processes and nutrient recycling process and nutrient mobility and nutrient I would say nutrient transformation process specifically depends on the soil pH. So that is why it is called master variable, and obviously here the pH is the negative log of hydrogen and concentration, where this H is the concentration of protons or H plus ion. And remember that every unit change in pH indicates tenfold changes in acidity obviously. So let us move forward and see the different grades of soil acidity. So you can see the soil acidity varies from 0 to generally 14, and obviously beyond the pH 7 it is called alkaline soil, and in case of less than 7 it is called acidic soil, or so we call it soil acidity. Extreme level of soil acidity can be found when the soil pH goes below 4, and extreme level of very strong level of soil alkalinity found when the soil pH goes greater than 8 or something like that. So depending on the soil acidity also we divided the ranges, we divided different types of soils. This extreme level of the soil acidity can be found in case of acid sulfate, active acid sulfate soil, and this type of acid sulfate soil having very low pH, sometime 3 and less than 3, and this type of acid sulfate soil is also available, is basically in India we can see this type of acid sulfate soil in Kerala, and also the acid pits are having very low pH, and the forest soils having the also very low pH, that is almost from 3 to 6, and humid region arable soils generally have the pH varies from 5 to near neutral condition, and in case of calcareous soil they have the pH starting from generally slightly alkaline to strongly alkaline soils, and sodic soils are having strong alkalinity. Sodic soils are generally dominated by sodium ions, whereas calcareous soils are generally dominated by calcium ions. So, you can see depends on the soil pH classes, also divided into the very strong, that is less than 5, and then strong, that is around 5 to 6, medium, then slight, neutral condition generally around 7, and then 7.5 is mild, and moderate is generally 8, and beyond 8 or 9 it is strong and very strong. So, these are also very important. So, what are the what are the similarity between these pH levels with different types of common materials? Obviously, a pH 0 you will see the in case of battery acid, in case of lemon juice you will find pH of 1 to 2 around, for vinegar it is pH 3, for beer or coffee you will get a pH of 4. In case of natural rain you will have a pH of 5. In case of pure water and milk, these are neutral in reaction, so we will have around 7. Seawater, baking soda will have around 8. Antacid tablets will have 9, and then milk of magnesia is basically having the pH of 10, and bleach will have the pH of 12, whereas the drain cleaner will have the pH of 13. So, you can see different chemicals which shows different ranges or different pH conditions, and we will get the extreme conditions in case of battery acid as well as in case of drain cleaner. So, common materials and their respective pH. So, this graph basically gives you a basic overview of how pH varies and what are the different classes of pH and what type of soil pH ranges you can expect in different types of soil, like sodic soil, then calcareous soil, then humid region, arable soils, then forest soils, acid peat soils, and active acid sulphate soils. So, let us move ahead and see what are the different sources of soil acidity. Obviously, the first and foremost source of soil acidity is the carbonic and other organic acids. Remember that in case of soil air, the soil air contains high carbon dioxide concentration due to and from respiration and organic matter decomposition, and this carbonic acid basically it reacts with water to form this carbonic acid, and this carbonic acid further dissociates to form this bicarbonate anion and protons, and these protons basically causes the acidity. And further accumulation of organic matter, obviously this organic matter, when there will be a high amount of organic matter accumulation, this will be decomposed, eventually those will decompose, and due to the decomposition process of organic matter they will increase the soil acidity. Third is the nitrification process. We will discuss the nitrification process in details when we will be discussing soil nitrogen in week 7. And so, nitrification is basically the conversion of ammonium forms of nitrogen to nitrate form. So, due to this, and it is an oxidation process, and you can see here ammonium getting oxidized to form water, proton, and dissociated nitric acid, that is H plus and NO3 minus, and these H plus or protons will basically causes the acidity. Remember this nitrification is basically a microbial mediated reaction. So, this nitrification ultimately forms these protons, and these protons will ultimately add to the acidity of the soil. So, this nitrification is a acid generating reaction or process. So, what are the other processes of soil acidity? So, sulfur oxidation, sometimes pyrite parent materials are there, as you can see here. Pyrite is iron pyrite here, it is FeS2, and this FeS2 when it gets oxidized, ultimately it will produce the ferrous sulphate and also dissociated sulfuric acid, and this sulfuric acid will produce these H plus ions, which will ultimately add to acidity of the soil. So, this is another important reaction for so sulfur oxidation is one of the major contributor of soil acidity. And finally, acid rain. Acid rain, different due to different types of combustion of the fossil fuels, different types of forest fire and other processes. When huge amount of sulfur dioxide and nitric oxide or nitrogen dioxide goes into the atmosphere, and then they react with the atmospheric moisture, atmospheric water vapor, and ultimately they produce different types of acidic different types of acids, and these acids generally come down to the earth surface during the different types of raining event, and we call it acid rain. So, when the sulfur dioxide goes into the atmosphere, reacts with the water vapor, forms the sulfuric acid, and ultimately finally reaches to the soil surface as a result of acid rain. This is also an important source of soil acidity. Similarly happens in case of nitric acid. Now, in case of nitrogen dioxide, and also different types of apart from this burning of the fossil fuels and different types of combustion of the fossil fuels and forest fire, also lightning events also generate these type of gases and ultimately produces this acid rain. As you can see here, H2SO4, when it reaches it dissociates to form the sulphate as well as protons, and also the nitric acid dissociates to form nitrate and H plus, and this H plus these ultimately forms the soil acidity. So, sources of the important sources of soil acidity. So, plant uptake of the cations is another important aspect. When plant root takes up the more cations, they tend to balance it by releasing the H plus ion and lowering the soil pH. So, as you can see here, this is a root interior and soil solution, and in case of this first example, obviously the plant is trying to uptake the ammonium, and as a result of the uptake of the ammonium, which is a positive cation, it want to counterbalance, it want to balance this uptake by release of these H plus ions from the root, and it is called an acidifying agent. So, this is another reason, or this is another cause of soil acidity. So, another important cause of soil acidity is the human induced acidity, and obviously excess of nitrogenous fertilizer, then acid rain, exposing potential acid sulfate soil, all these are basically anthropogenic in nature. For example, when we use excessive amount of nitrogenous fertilizer, that also ultimately forms the nitrification process, and this nitrification process generates this acids, and also acid rain, burning of the fossil fuel. It is a human driven process, and exposing potential acid sulfate soil, which get completely oxidized to form the more acidity. So, these are the sources of acidity. As you can see here, obviously pyrite is getting oxidized to form this ferrous sulfate and sulfuric acid, and this ferrous sulfate is further oxidized to form the iron oxyhydroxides and further sulfuric acid, and elemental sulfur also get oxidized sometime to get the sulfuric acid. So, all of these are human induced processes, and these human induced processes ultimately leads towards building of soil acidity, and sometime it is very harmful for soil biological different types of soil microorganisms and macroorganisms, as well as different types of soil chemical processes. And also you can see here the ammonium sulfate, it is an important nitrogen fertilizer. When it get oxidized and ultimately forms the nitric acid and sulfuric acid, these also adds up to the acidity of the soil. So, let us move ahead and see what are how the balance between production and consumption of H plus ions are maintained. So, here you can see the main process that produces or consume hydrogen ions in soil systems are given. So, acidifying or H plus ion producing processes are given here. Obviously, the formation of carbonic acid from carbon dioxide, you know that due to the due to the and this carbon dioxide basically generates due to the respiration action of microorganisms. Acid dissolution such as RCOOH, and you can see the dissolution of the acid which further dissociates or dissociation of the acids which further produces the H plus ion. Then oxidation of N, S and F compound we already showed you, and atmospheric H2SO4 HNO3 deposition in the form of acid rain, cation uptake by the plants I showed you, accumulation of acidic organic matter, and then cation precipitation such as you can see aluminum when reacts with the water to form this aluminum hydroxide and also generates 3 hydrogen or three protons which so this is basically hydrolysis process, and this adds up to the acidity. So that's why aluminum is also considered as an acidic cation of the soil. So this there is a common everybody asks why we consider aluminum for as an acidic cation, because due to the hydrolysis process it generates the H plus ion. So that's why we call it as an acidic cation. And also you can see here silica is reacting with the aluminum hydroxide and calcium, and you can see ultimately it is also producing the H plus ion which is acidic producing. So deprotonation of the pH dependent charges, obviously you can see, if you remember the pH dependent charge and pH dependent charge occurs acidifying process if you remember the pH dependent charge occurs at the edges of the mineral like kaolinite and aluminum oxides, and it is depending on the pH. So in the alkaline condition, when there will be sufficient amount of hydroxyl anion, these H plus will deprotonate and comes into the solution to form H2O. So it is a deprotonation process, and ultimately it will add to the pH of the soil. And alkalinizing alkalinizing or H plus ion consuming processes are also given here. Inputs of bicarbonates and carbonates in the form of lime, and anion protonation, you can see here anion protonation, reduction of N, S and Fe compounds, it is quite obvious, atmospheric calcium magnesium deposition because these are basic cations, anion uptake by the plant, obviously when there will be anion uptake by the plant more cations will be released. And the specific adsorption of anions and cation weathering from minerals such as 3H plus, when aluminum hydroxide reacts with these protons to form this aluminum ion and water molecules, this is another H plus ion consuming processes, and also protonation of the pH dependent charge. So, this is the opposite of this reaction. So, in case of acidic condition, remember, in case of acidic condition protonation of the pH dependent charge occurs, and in case of alkaline condition deprotonation occurs. So, these are the processes for making the balance of for the production and consumption of H plus ions. So, how aluminum causes the soil acidity? Obviously, the H plus releases aluminum from crystal structure and aluminum occurs. So, here you can see this is important process. So, you know that aluminum is present in the crystal structure of the clay minerals, and it is bound to these hydroxyl groups at the edge of the mineral, and when we add when the added H plus ions and these H plus ions get absorbed into the clay surfaces, it basically makes this crystal structure less stable, and ultimately these three molecules of water get released, ultimately releases the aluminum from this crystal structure, and this aluminum is is present ultimately at the edge of the mineral as exchangeable Al3 plus ion, and these exchangeable Al3 plus ion basically are in equilibrium with the Al3 plus ion in the solution, and these Al3 plus ion, exchangeable Al3 plus ion, ultimately helps in hydrolysis of the water to produce the H plus ion. As you can see here, this is the hydrolysis of the water So, if we consider this process, this reaction, this Al3 plus reacts with the water and ultimately produces the H plus ion, producing this aluminum this compound. And the second step, it is also again had releasing another H plus, producing LOH2, and further it is producing LOH3. So, each aluminum releases 3 H plus ions. So, that is why the aluminum is considered as an acidic cation. So, apart from H plus, aluminum is also considered as an acidic cation, because it produces H plus ion, or acidic, it is basically producing the H plus ion due to the hydrolysis of water. So, there are different pools of soil acidity. Basically, the pools of total soil acidity, generally it is a combination of active acidity plus exchangeable acidity and residual acidity, and there is another term called potential acidity. We will cover at this later. So, active acidity, exchangeable acidity and residual acidity are very important, and as far as the quantity wise is concerned, this residual acidity is always higher than exchangeable acidity, which is further higher than active acidity. So, let us see what are the active acidity, exchangeable acidity and residual acidity. So, active acidity is the acidity usually measured by using the pH of the soil solution, and active acidity basically represents the H plus ion concentration in the soil solution, and it can be easily balanced. And when we measure the pH of the soil solution by a pH meter, it basically measures the active acidity. What is exchangeable acidity? Now, exchangeable acidity primarily caused by the Al3 and H plus ion. As you know that Al3 also acts as the acidic cation. So, when we combine the Al3 plus H plus ions in the exchangeable sites in the soil mineral, or the exchangeable cation, then we call it the exchangeable acidity, and it can be measured by using unbuffered salt like KCl. As you can see here in this reaction, these Al3 plus and H plus are present in the exchangeable sites, and we are adding some unbuffered salt like KCl, which is basically replacing all the Al3 plus and H plus ions and replaced with the K plus. So, it comes into the soil solution. So, it can be measured, then this aluminum and H can be measured. So, this is an example of exchangeable acidity. So, we have covered the active acidity and exchangeable acidity. So, what is the residual acidity? Residual acidity is basically primarily caused by the Al3 plus and H plus in non-exchangeable sites in soil colloids, basically in the clay and organic matter, and they are basically bound cations and released using the liming material. So, you can see these are basically present in the non-exchangeable site, and when we are adding the calcium hydroxide, it is basically releasing these and producing aluminum hydroxide and replacing with the calcium. So, this is an example of residual acidity. So, basically total acidity is the combination of residual acidity, inactive acidity and in exchangeable acidity. There is another acidity pool called potential acidity, and it is the maximum amount of acidity which a partly or totally reduced soil may contain after it has been completely oxidized. Generally, you can see this potential acidity in case of acid sulphate soils, and so we have covered the 4 pools of acidity. Remember that whenever we go for ameliorating the soil acidity, by adding the liming material, we neutralize only the active acidity. So, this is very important. Primarily, we are neutralizing the active acidity. Now, cation saturation percentage, we know that the proportion of the CEC which is occupied by a given ion, and we already covered what is percent base saturation. So, proportion of the CEC occupied by non-acidic cations like calcium, magnesium, potassium and sodium, and acid saturation is basically proportion of the CEC which is occupied by acid cations like H plus and Al3 plus. So, you can see here if the CEC is 20 centimole per kg with the 10 calcium, with this 10 unit of calcium, 3 magnesium, 1 potassium, 1 sodium, 1 H plus and 4 L3 plus. So, what is the magnesium saturation? Obviously, we will get 3 by 20, that is 15%. What is the base saturation? That is 75%. So, obviously, these are important aspects for calculating the acid saturation as well as base saturation of a soil. Uh, so, what is the relation between CEC and types of cations? You can see that although there are 4 different types of soil here, hypothetical soil. So, here in case of soil, you can see although the acid saturation is changing from soil A, that is 78% to 62%, then 33% to 14%, they have implication only on the pH. So, acid saturation is interlinked with the pH. So, as the acid saturation is increasing from 14% to 78%, the pH is getting decreased. However, that may not be reflected in the total CEC, because you can see here soil B and soil D are having the same CEC, that is CEC equal to 21. However, soil B is less acidic than the soil D. So, basically here we can see that acid saturation has an implication on the soil respective soil pH. So, why should we consider soil buffering capacity? Now, better buffered the soil, better it resists the acidity from external factors. Remember that a better buffer soil is always good for for resisting any abrupt change of soil pH when we add different types of external factors. And buffering capacity helps us to determine the amount of lime to be applied to raise the pH, and higher the CEC, more the buffering capacity of the soil. Obviously, they have more reserve then, and compensating only active acidity will have little consequence while liming. Therefore, we should also consider the other pools also. So, effects of, let us see the what are the effects of the acidity. Obviously, as I have told you at the beginning of this lecture, different types of microorganisms are present at different levels of soil acidity. Obviously, fungi are more or less present, as you can see in the acidic soil. However, bacteria is present only at near neutral condition, that is from 6 to 7. However, when there is a very low pH, the bacteria cannot thrive, and most of the nutrients, the thickness of these bars are basically representing the availability. So, you can see N, K, S, all these are more available around the along the pH of near neutral pH, that is from 6.5 to 7.5, and at the pH acid pH condition, which is less than 5.5, all these are not available, or the availability decreases. So, most of the most of the cases you will see that the availability of the mineral nutrients are decreased. However, you can see here opposite trend for aluminum. So, aluminum toxicity increases in case of acid soil. Aluminum toxicity is very harmful for the growth and germination of the crop, and manganese, iron and hydrogen toxicity also also occurs, and nutrient availability to plants affected due to the acidity. It can also affects the microbial growth, and optimal pH for plants are basically also affected. So, maintaining an optimum pH is very important for for an optimum soil acidity. So, guys, let us wrap up here, and in the next lecture we will try to finish this soil acidity, and then we will start the soil alkalinity, sodicity and other topics. So, I hope that you have you have gained some knowledge about the soil acidity and how soil acidity occurs due from the different factors, and what are the different pools of soil acidity. So, we will stop here, and from in the next lecture we will see how we can ameliorate soil acidity, and using different types of liming materials, and what are the other important factors for considering the amelioration of the soil acidity. And so, till then have a good day, and we'll meet in the next lecture to discuss these things in details. Thank you.